Awesome. Thanks, Amanda. My name's Tim Roberts. I'm a senior data and analytics consultant from Stellar Consulting, and this is my presentation. So Stellar were brought in by Trustpower to overhaul generation analytics with some new technologies, methods, and a couple of new reports. So just quickly what I'll cover today, what our objectives were, what the process was we went through, and just a couple of handy tips and hints along the way. What the results were, and I'll show you one report, and just some final thoughts. So just a little bit about Trustpower Generation. They own 38 generation stations around New Zealand, worth about $2 billion. And I've got 110 staff, so it's a fairly big operation. So firstly, what were our objectives? So we wanted to investigate analytics in the cloud for Trustpower. We wanted to be able to demonstrate a solution that would show how to get data into the cloud, how to get data out of the cloud, and also how to move it around and transform the data in the cloud. Also wanted to demonstrate what the performance of the cloud was going to be, what it was going to cost, and how the analysts were going to interact with it. So we set up a little bit of a proof of concept. Proof of concept, we had a couple of source systems. One was Maximo, which dealt with asset information, such as turbines, and eBusiness, which had financial transaction information from the generation projects. There's some existing reporting there in Power BI and Excel. First report we had to do was the asset spec report. That basically was counts of assets by like location or classification, but also showing the kind of the detail for each asset, what the individual specifications of that asset was, like say the rated kilowatt hours or kVAs. The next one was the asset cost report we had to do, which involved linking up the financial transactions with the individual asset itself, so we could see how much it cost over time. So what was the process we went through? Firstly, we had to gather some requirements. So I got out my handy notebook, and we had a bit of a session with the analysts and a couple of the reporting users. There are a few things that kind of shone through. Firstly, that the analysts still wanted to retain their ability to be able to write SQL, produce their own reports, but they wanted that the process of building the data for the reports or analysis to be quicker and easier for them. The non-analyst people, they wanted a configurable solution, so be able to get insights from data, but without having to rely on analysts too much or writing their own SQL. So when you're gathering requirements, sometimes a handy notebook or a laptop is good to type some things down, but sometimes I really think a picture is worth 1,000 words. In this case, we used what's called a rich picture, which is actually a formal thing, even though it kind of looks like I've just drawn stuff on the whiteboard. Google it if you don't believe me. Its sole purpose is just to gather information and not worry too much about structure or process or modelling the information in any way. It's more than one-dimensional, so it doesn't just focus on like the data sources or the process flows. It also focuses on the softer information, like any conflict or issues. You can put people in there and what their thoughts are on the system. Just any general tidbits of information that people kind of drop in the session. And it's just a really quick way to get a picture of what's going on, particularly in a complex system where you've got a lot of different things going on. You build it with the people in the room, and so not only are you building that picture, but they are as well. And as I've done with the overlay, you can pretty it up in draw.io or Visio or something, and it becomes a really nice communication piece for later on in the project. It can be very useful. And likewise, pictures are really good when you're trying to figure out what you've actually got to try and build in terms of the dashboard or report. Rather than ask the engineers 20 questions about, okay, what do you want to see here and there and there, I said, look, just draw me a picture of what you're thinking, and it just cuts straight to the chase about what they want to see. So yeah, it really helps you get to the position of having a vision of what you need to build in terms of a dashboard or report. So for a design principle, we went with less SQL is more. So if you've got a couple of data sets like Maximo or in EBS, and then you've got some SQL code that you use to put data together to put into an Excel report. Maybe you've got some more reporting from Power BI, some more reporting, more code. Eventually, over time, this builds up. You've got a lot of SQL code to try and maintain. Some of it probably even gets lost. And you'll find a lot of that code is actually quite similar, like it may have been copy and pasted between things. Different people come up with slightly different ways of doing things. So you'll find there's a lot of objects that are similar throughout those reports. And some of these reports also have metrics which should equal between the reports, like say the count of operating assets. Problem is when someone comes along and fixes one bit of code, doesn't fix the other one, suddenly they don't equal. People get confused about what's right and what's not. It's all just a bit messy. It's fine. Maybe I've only got 5 bits of code on the screen, but when you've got 50 reports, it becomes a bit of an issue. And when analysts leave, as we've had someone leave recently, sometimes it becomes quite hard to sort of unpick that mess. So what did we go for? We went for a central data store, in this case in Azure Data Lake. We brought the data in from Maximo and EBS into there. And we created a few shared analytic data sets. So I went through some of that code and found those common business rules that were being applied in SQL, found those common objects that were prevalent through those bits of code. And I just created some data sets that people can just reuse in their reports. So an example was like the asset object was quite commonly used. So people would deduplicate some assets that were there in error. They'd work out the condition of the asset. There was some SQL for that. There was a text field that was split into 3 text fields using like substrings and stuff. I just did that for the analysts. And it kind of meets that requirement of where the analysts, they wanted their job for data preparation and that to be a little easier. So you do things for them and it makes their job a bit easier. And as well, you get the benefits of having some more consistent reporting. So what did we actually build? So this is kind of a diagram of the high-level architecture. So we bring the data in through a data gateway on a local server, provides a secure tunnel into the data lake, and we bring in the data with some Data Factory copy jobs. The SQL's written in Azure Databricks, which is like a hosted Apache Spark platform. It's basically you pay by the hour that the cluster's up. It's very scalable. If you want more worker nodes on your cluster, you just kind of slide a slider and you have more worker nodes. Yeah, you can do SQL in it. You can write Python, Scala, and it does everything in memory as well. So it's quite high performance. The scheduling is done with Data Factory, and that kind of organizes the pipelines as well. It tells which notebooks to run in which order. And we put in a configuration framework and built-in PowerShell, mainly for Data Factory. Data Factory has a nice UI, but I prefer to script things. I find it ties in a bit better with change control. It's a little bit more repeatable in terms of deployment. Just means we can push a button and then it just builds the whole solution, but in the production environment. It just takes values from like a CSV file, like say the dataset name and a dataset path if we're creating a dataset object, and then it builds the JSON, which then automatically gets deployed into Data Factory. So it gives a bit of a consistent framework and saves some time as well. So I just thought I'd cover what a data lake is, and just in case anyone hasn't come across it. The best description I could kind of think of is like a hard drive in the cloud. This is what a data lake looks like. So it's got files and folders. Yeah, it just looks pretty familiar. How do you query a data lake? So a lot like just a normal relational database, it seems. You can create tables in there. Azure Databricks, it allows you to do that. Just point a table at a path in the data lake, and it creates a table for that data. You can then just write normal SQL using that table. And there's the picture, the little graph there. So that's the notebook style of development of Azure Databricks. Means that you can basically either view your data in a tabular form like you normally would in like a SQL developer or something like that. But you can visualize it as well. Or you can use like R or something like that and create a nice graph for it. Just a few observations about a data lake, because I'm kind of from a relational database world. It's got limitless storage. Both Azure and AWS kind of allude to that on their website. Hosts have variety quite well, so you can upload any old file type there if you want images or audio or anything like that. There's no concept of a primary or foreign key when you write to a data lake. You just got to watch out for duplicates. It's an important thing. Storage is a little more separated from your compute. So with a normal relational database, I remember having, when people were running a lot of queries, sometimes the jobs would slow down and your jobs would take a bit longer. And it's quite hard to just say, okay, well, I want to increase the processor power for that storage. With a data lake, you can you just create a new cluster, and then you can start using that to use the shared storage. So it's a little bit more scalable in that respect. And it's dirt cheap. We don't have that much data in the moment. It's kind of under 40 gig, but it's just in the realms of a couple of dollars a month for the storage. So yeah, it seemed pretty cheap to me. So what were the results? So I'll show you the asset specification report. This is a stator. It's the big red round thing. There's a lot of copper coils in it. There's usually a big rotor that sits in the middle. It's part of a generator, and it spins around and how electricity is made. So this is the report for the status. I couldn't show you the asset cost report because there's some sensitive data in there, but the engineers were kind enough to show off the asset spec report. So it's drilled into the Kaimai scheme at the moment, which is up by Tauranga. You can see the condition of the assets. Most of them are good condition in the blue there. You can see the type of stator, either synchronous or asynchronous. And then you've got a detail table there with all the different specifications for each individual stator. So it's a little bit interactive in that the engineers can just click on the ones, say, that are in fair condition, and it will highlight those ones for them. There's a little graph as well for the age of the status. So some of this equipment is quite old. Well, it seemed old to me. It probably isn't old to engineers. But yeah, average age of 38 years. So yeah, it's kind of a high level, low level view of the data. And so this is, it's below that little sign, but this is the stator report, but there's also other types of assets, and there's a tab for each asset type. And to meet the requirements of making it easier for non-analysts to get data insights, if you want to create another report on a different asset type, you just need to copy a tab, the one that you think looks like the one you're trying to replicate, and change a few like filters, and then they've got a new report for a different asset type without writing any SQL at all. So it's quite good in that respect. So for the results, for the cost, for our bill for February was about $30, which I thought was pretty reasonable. For the performance, the hardest thing I found was actually getting data into the data lake. Load time was 45 minutes, and that was one table in particular that took 35 minutes to load. I couldn't find a good incremental update key, like a date time, to load it in with, so we've got to load the whole table each day. But the rest of them were quite easy with just an incremental load. Processing time in Azure Databricks, yeah, as I said, it was quite a high performance setup. It only took 5 minutes to process the data. As for what the analysts would use to interact with it, thought Azure Databricks was the way to go. They can write their SQL, they can do their machine learning or graphing in Python or R if they choose, or even Scala if they like. So just a few final thoughts to tie things off. And it's the little things that can really make a difference to a report. I say this just because in the asset cost report, we had to deal with work orders. And work orders have a parent-child hierarchy that can be 6 or 7 layers deep. And I thought it's quite hard to visualize in a report. So I thought I'd put a drill in so they can start at the top of the parent-child hierarchy and then investigate downwards. I didn't really have to do this. They hadn't asked for it, but I thought I'd do it anyway because I thought they might find it useful. And it turns out they did. One guy said when I showed them to it, where have you been all my life, which I thought was pretty good feedback. So yeah, it's often those little things. If you get those little details right about a report, it can make a real difference and gives kind of an air of quality about a report, I guess. And sort of just the key to long-term success, I guess, of a reporting system is it's more than just one person or team, or even technology, I guess. Just because you drop a piece of technology in doesn't mean it's going to get used. So I had to work with all these different people throughout the project, and it's going to take every one of them, I guess, to support the project ongoing. And it kind of puts a little bit of focus on that leadership aspect. Where you've got to make sure you support all of these people to ensure they know what to do to keep things going. So yeah, that's pretty much it. Are there any questions? Hello? Data issues. As you would know, this is Larissa, by the way. She was one of the analysts who helped me out. She's from TrustVer. So we came across a few data issues, like the deduplication of assets, also joining the EBS to the Maximo data was interesting. We couldn't kind of do it at a level of granularity we wanted to, so we had to kind of go up a level to the GL code to match things. But I think you kind of find that with most systems I've worked with, I guess, or most projects I've had to do, always come across some data issues. I guess it's just par for the course. In front. I just got real quick. How long did the project take? How long is a query run across data lake? Yeah. And if you're adding another data set, how long would that take? So it was about 6 weeks all up. What was the second one? It was query time. So anything between like 30 seconds and I think the longest one was about 6 minutes. Depends on the data set, but from scratch, like bringing it in from raw. So it's very quick because of the framework we put in. It's just like a copy and paste of a couple of lines, and then that brings the whole data set into using Data Factory. And then I guess it depends on the logic. If it's complicated logic, I don't know, maybe a few days to work the SQL logic out. But yeah, I guess it depends on the data set. But it's very quick to get it into the data lake. Yeah, so you're saying about when like analysts are just writing lots of SQL everywhere? Yeah, so I think the key to that is kind of that last slide where, it takes all of these people to work together on a solution. So I guess the plan is that analysts can still write their own SQL, but if they want to, ideally it'd be good if they could contribute to those core data sets, maybe just add on a column to an existing object or create another object that can be reused by other analysts. It's kind of like working on a big shared piece of code set, I guess, rather than just doing their own thing. And it, when they leave, it gets forgotten, and then the next analyst comes along and they build their own SQL that's, they've got to start from scratch, and it's completely different to the other one, which I say all the time. Yep. So there is one fact and sort of dimension tables in there. So you can split it, you can organize a data lake. We organize it into areas, like we've got an analytical area, and that's where we put like a star schema type structures. But I tried to keep the modeling sort of less away from those formal, star schemas or like data vault type ones, because I wanted the analyst to be able to play a large part in supporting this. And that's where I went for like it just having an asset object or a work order object. So they would kind of recognize them as just normal business entities that they always work with. Yeah, I guess it's probably where you would use like a fact or something like that to get around that problem. Yeah, so I guess it's kind of whatever situation you got to deal with, you pick what you want. What do you mean by that? Oh yeah, no, we didn't use Gen 2, but yeah, we will probably look to upgrade into Gen 2 because when we started, Gen 2 wasn't available. But yeah.